Hello, legends! This is Mr. Mays and Miles, and we're here to give you some advice for the Unit 9 quiz pro tips on goodness of fit, chi-squared goodness of fit, and chi-squared tests in general, both for independence and homogeneity. So, together, we're just going to talk shop with you. Here are a couple of things you might want to keep in mind, right? You want to tell him? He can't tell you yet. He doesn't know words. Oh, that was a good try. We'll try for the next one, yeah? Thing one, there will definitely be at least a multiple choice question or two where you have to handle a p-value. And I don't necessarily mean interpret, but you should be able to interpret a p-value in context. What I'm speaking about specifically is being able to look at a question, be given a p-value, and then determine if we would reject the null or fail to reject the null under certain circumstances, right? So here's the alpha, what would happen? And you have to be able to choose the one that says we would reject or fail to reject the null, whichever one's correct. And we would find convincing evidence or we would not find convincing evidence for the alternate. So that's the first thing you should feel comfortable with. Boo. 2, remember that minimum sample size or number of trials, right, depending on which, for chi-squared, if you take those, right, and you multiply those by the expected count that is lowest, that will tell you the minimum number of people that you have to run through, right? So the minimum sample size required for a chi-squared test is going to be determined by taking the lowest expected count, right, which would be p, the lowest p though, and multiplying that by the sample size, and that number that we create should be greater than or equal to 5, right? So to just make that clear, if I'm looking at the probability of getting different color M&Ms, right? And you say, hey, here's the distribution. What is the smallest sample size that will work? I will take the lowest proportion for a particular color of M&M. Let's say that there's a 0.1 chance of getting a red M&M. And I will go 0.1 times some number n should be greater than or equal to 5, right? I will then divide under, and what you get there, Miles will tell you, is 50 would be the minimum in that case. Okay, rolling ever forward. Remember that sample sizes can be different and that that's okay, right? We've been in these situations before where it's like, do we need the same amount on each side? Only paired t-tests require the same amount in each sample, right? Because technically it's not 2 samples, we're combining them into 1 sample. For chi-squared test, you tell them, Miles, we don't actually care. Sample sizes can be slightly different. The key is not to have the same sample size. The key, on the other hand, though, is to make sure you've got your null and your alternate correct. So, one of the things that you will note is that the null is almost always, unless stated otherwise, the null and the expected values for the null, yeah, I know he gets excited about the null, is that they will all be equivalent, right? So, for example, if I'm looking at M&M colors in a bag of M&Ms, the assumption would be if there are 5 colors, that there would be a 0.2 chance of getting any particular M&M. Unless stated otherwise, that would be the null because it would be an equivalent distribution. Uniform, you could say, exactly. The other way to think about it also is just that, like, independence will always be the null, right? They're independent, they're all just equivalently present, no one is, there's no dependency there. Versus the alternate will be a dependency or the idea that they're not evenly distributed, right? And be aware of that. Remember that for two-way tables, right, the degrees of freedom, and so this is for chi-squared tests for homogeneity and chi-squared tests for independence. For those two, the degrees of freedom are rows times columns, or if I don't give you rows and columns, the way to think about that one is number of categories in variable 1 minus 1 times number of categories in variable 2 minus 1, right? So just make sure that you're looking at the two sort of variables or the variable in the across the different samples, and you're looking at the number of categories in that particular variable, subtracting 1 from that and multiplying it by the other variable's categories minus 1. Okay. Remember that if we're looking at two categorical variables, so two variables that are not about numbers, they're like percentages, and we're looking at like yeses or nos or whatever it is, two categorical variables, and we're saying, gee, I wonder if they're related in some way. That's a chi-squared test for independence, like always. That's what that is. So if they're like, oh, we want to see if these two variables are in any way related. My hair's peeking out of my hat. If you want to see if these two are in any way related, you already know. And if they're categorical variables, you already know what this is going to be. We're checking for independence. It's going to be a chi-squared test for independence. And then be able to run a chi-squared test. You knew this, but obviously you need to be able to run one for goodness of fit, but I'm warning you for this quiz, be able to run a chi-squared test for independence or homogeneity, and know how to read the two-way table for it, know how to input the values, just like you did when you were practicing for the review, and know how to do it seamlessly. Every part of phantoms, boo, right? And know every component, and don't get lost, and be able to do it really, really, really fast, because I want you to be able to zoom through this quiz and do brilliantly on it. And then the last thing I will say is be able to identify type 1 and type 2 errors. Some people forget those because we haven't used them since probably a test or two ago. We haven't really gone into detail. So be able to identify type 1 and type 2 errors for chi-squared tests and be able to give them in context. I need context, context, context. And that's it, if you can believe it. Just a quick 6-minute or so video. I'm so proud of you guys. Keep studying, keep it up. Make sure to get your stuff in for your project and your debate. And I'm so thankful to be your teacher, as is Miles. All right, we adore you guys. Take care of yourselves. This is Mr. Mason Miles signing off.